So what you're going to have is you're going to find a bag that has two of these connectors in them. And then you're going to fish out one of these big spools of cable. These are 75-foot 4-conductor loudspeaker cables, okay? Because that's a length that we're missing in the shop. We don't have very many of that length. Now, you may recognize, kind of, these connectors. You might have heard people call them Speakons, right? Speakons, which is a woefully inadequate description. Because Speakon is a connector design, but there's several different versions of it. So it does say Speakon on this. This is an NL4FXX WS. So these used to be black and blue up until basically a year ago. And what these are is, we use these for loudspeaker connections. And we will usually call them by their more descriptive term, which is like NL4 or NL2 or NL8. The number indicates the number of wires that you can terminate into the connector. So NL2 would only have 2 wires, NL4 would have 4 wires, NL8 would have 8 wires, okay? That's a much better description because it tells you what it does. Because Speakon is not necessarily a Speakon, is not necessarily a Speakon. So you gotta get more specific. But the interesting thing is they've always been, it's at least the cable connectors for the Speakons have always been something that you can do without soldering. But eventually, most of us started soldering them because they just weren't super reliable unless you soldered them. The problem is because it's technically possible for them to run high voltage signal through them, which is kind of what you get out of a power amplifier that goes into loudspeakers. They were never UL certified because UL does not like soldering high voltage systems. They don't like soldering those kind of things. And so anyway, Neutrik, who makes the connector, they released this new design recently and discontinued the old design in favor of this one. Why? Because this one is now, they got it UL certified, which means it now adheres to safety standards for high voltage systems. And if you follow the manufacturer's instructions in putting it together, it won't scare the fire marshal, basically. Okay? Ultimately, that's a good thing to have these UL certified. That's been a kind of a problem with this connector for a long time. But here's the catch. It seems as though in order to get them UL certified, they had to design it in a way that people like me would not be able to solder it. Because it's the soldering of it that makes the fire marshal nervous. Why? Because here's what I think it is. I'm not a fire marshal or a safety inspector or anything, but I think what happens is when your high voltage tends to come with high current as well. And high current generates heat. When you put too much current down too thin of a wire, it generates heat. If you do that enough, could you generate enough heat to melt the solder? And if you did, what kind of chaos would that cause inside the connector? On a high voltage system that then shorts and starts sparking and catches on fire. That's my guess. I'm not aware of any stories of that ever happening, but I suppose it's theoretically possible. So Neutrik designed this in a way that makes it impossible to solder it, which really bums out people like me who have had many NL4 Speakon connector fail on me because the wire jumps out of the terminal because it wasn't soldered. But can't do anything about it because they're not even selling the old ones anymore. So we got to learn how to make the new ones. Now, here's what they look like. So they come in a few different parts. So you've got the actual piece that the wire goes into. And what you'll notice is the wire goes in there, and then you terminate it there. And I've been wondering if it's possible. I don't think, it looks like it's not possible, but I've been wondering if it's possible to remove the screw and the little cover on it so that I could solder it. But I haven't tried yet. But I'm going to give them the benefit of the doubt, and we're going to try it and see if it works. Because here's what Neutrik says. They say, look, if you do this right, it should be fine. And doing this right requires special tools, of course, which has got everybody up in arms. It actually, according to Neutrik, to do it right, you need a torque screwdriver, which nobody uses a torque screwdriver for anything. I mean, I don't know. So I bought one, okay? I'm not going to make you guys buy one because these are expensive. So I bought one, and I want you all to at least try it. I actually don't think you're going to need to use a torque screwdriver on them every time. If you're going to make a bunch of these, I think what I want each of you to do is to at least do it once with the torque screwdriver so that you can get a sense for how tight you have to tighten these screws. Just get a feel for it. It's not as tight as you might be inclined to do it. It's actually, this thing clicks much quicker than I was expecting it to when I put it in the right torque. So I want to give you a chance to try that out and just like feel that. But I think, once you get a sense of how tight it is, my guess is it's probably not like super important to hit it every time. Unless you don't have that muscle memory. If you're worried about that muscle memory, then by all means borrow this torque screwdriver and do it like every time. But it also requires you to torque the boot to a very specific torque, and I think that's because of this strain relief. So this is the strain relief for the thing, and all these little things are supposed to gather together in a very specific way on the wire, and in order for that to stay put and not put strain on where the wire actually goes into the connector, I think this has got to be gripping in a very specific way, which means you got to tighten this to a very specific torque. Well, that's a whole other tool. So that requires an inch-pound torque wrench, which I went and bought as well. And to further up the ante, in order to tighten that boot on to a torque, you have to have something that you can attach this socket to that will also attach to the NL4 connector. So that's the first thing, is they made this thing. So here's what it looks like. This little part goes into here, like that, right? And then this goes on here, and now you can spin this thing, right? And then the boot is on the other end, and you got to work that too, and that requires this tool. So you stick the boot inside of this tool, which I still have not I've only messed with this a little bit. I haven't yet figured out exactly the right alignment for this thing. Feels like it should be that. Yeah, there we go. Okay, so now you're sitting there and you're holding the boot like this, and you're holding the connector like this, and then you can, until this clicks, and then it'll be the right thing. That's the dream. Okay. So anyway, I'm going to show you how to do this. I've only done it twice in my life before I showed you how to do it. Oh, also, in their infinite wisdom, they didn't make enough of the special tools. So these are hopelessly back-ordered, these things. I mean, I managed to score 3 of each, but I had to buy them from 3 different vendors to ultimately get all 6, because Neutrik didn't make enough of them. So you can't even get them. Like, you have to have these tools to put it together, and they've got plenty of connectors to sell, but not enough tools. So whatever.
Is that on the tool list?
No, I didn't. You don't need to buy that. That's another one that I'm hoping, once you get a feel for how tight it used to be, I don't know that you need to use the torque socket every time, but I want you to give you a chance to at least try it. Okay, so if you look at this connector, these are numbered. So this one says 1 plus. That one says 1 minus. So in other words, positive, negative. So an NL4 can carry ultimately 2 signals because it takes 2 wires per loudspeaker signal. So positive, negative for signal 1, and positive, negative for signal 2. Okay? And it's very important that you get those in the right place. So I'm going to stick this in here with the 1 plus facing up, and then we're going to work on this cable. Okay? So first thing I'm going to do is slide my little piece of heat shrink on. Slide the boot on. Very important. Don't forget that. Or you will regret it. Somebody having flashbacks? Or to forgetting the boot? Yes.
Like 5 minutes ago.
Ah!
I'm going to restart this.
Amazing. All right. So now, what Neutrix said, if I can find my tape measure, or my ruler, here it is. So, they want you to strip this to a very specific length. But it's basically about an inch. Which is about what we would normally do anyway, okay? So, they specified it in millimeters. So I'm going to just take this and spin this like I've done before. Okay. Now there's no, this wire is weird. Normally you would have some twine in here on this one, but when I had to order this spool, this was all they have. So I think technically this is what's called riser wire, or riser cable, which is designed to like be run like up in a plenum space, like not necessarily in conduit, but not necessarily being coiled and thrown around a lot. So, I don't know, these cables might not turn out to be super durable for our use. But because of that, because they're not meant to be handled a lot, they didn't put a lot of effort into making them hold their shape. So these are going to feel kind of weird as you're working with this jacket. I think it'll be fine for our purposes, but just know that usually it would be better than this. But there was a cable shortage when I was ordering these, and this was the best they had in stock. Okay. So you got basically 4 wires in here, along with this little piece of string that you're going to want to cut off, either with your scissors or your knife or whatever. All right, so you've got white, black, red, green. Okay? Now, white is going to go to 1 plus, black is going to go to 1 minus, red is going to go to 2 plus, and green is going to go to 2 minus. Make sense? Very important. It doesn't matter, actually. The wire inside doesn't know what color the jacket is. The only point of the color is so that you make sure you put the same wire on the same pins on either side, right? So if you get it wrong, it's fine. It just has to be wrong in the same way on the other end.
So like it could just be white, white, like red, red. Like
yeah, I mean, like you could do white, green as a pair and black and red as a pair if you want. That's fine, but it just has to be whatever wire you hooked up to 1 plus, you have to hook that same color up to 1 plus on the other side. Generally speaking, the convention that most of us use is what I just told you. White, 1 plus, 1 minus, black. White, 1 plus, black, 1 minus. Red, 2 plus, green, 2 minus. Okay? Now, what you're going to do here is you're going to strip off a teeny tiny amount. So I'm going to show you about how much you're looking for here, because you don't want any wire sticking out from the inside of this little hole you're going to stick it in. You want the jacket to be pushing up against there. So it's a very, very tiny amount of wire that you're going to strip off. I will, like that. Okay. So here is what you do. You twist it so it's kind of tight. You slide it into that hole, and you get your torque screwdriver, and you twist, twist, twist until the screwdriver slips. And it'll slip when you've gotten it to the right torque, or the right tightness. So here it goes, I'm almost there, and it slipped on me. So now I know it's as tight as it needs to be, okay? Again, I think once you get a feel for that, you probably could get close to that torque every time. You don't necessarily need the screwdriver, the torque screwdriver, but it uses a T8 driver. So that's why I had you get a screwdriver that had a T8 bit on it. Okay, so now we need to do the 1 minus, which will be this one. So let me get the black stripped off here. Again, you don't want to take too much off here, because you don't want any sticking out. That's what makes the fire marshal upset. All right, so I'm going to stick this in here with the 1 minus facing up, and I'm going to try to get this in there. So the good news now is, of course, no burned fingers, because there's no soldering this. But you want to push this all the way in so that that jacket is touching the end of the connector. And while you hold it in place, you tighten the screw until you reach the tightness that you need. Okay? Now see how I probably stripped too much off of this one? See how there's a little bit of that copper exposed? That's not ideal, but they do have these little bumpers to protect from that so it doesn't short. So I don't know that I necessarily need to do that again, but that's what you're trying to avoid. Okay, 2 plus, which is red. This one. Same deal. See if I can get this in here. Now, the other thing you want to watch out for is that thing I just did, which is getting one of the wires caught and it folds up on you. You want to get all of the wires inside that hole. There we go. Okay, and then we can do the green. Using my pick to guide that one in. Get in there. There we go. All right. And twist, twist, twist until it clicks. Forgot the second boot. This one has 2 boots. I forgot. All right, here we go. I'll take it off and do it again. See, even I forget the boots sometimes. Don't beat yourself up when you do that. Okay, so this goes on this way. You want the flared outside pointing away from the end. Okay, like that. All right, let me put this back on now. Where'd the thing go? There. Okey-dokey. First one. Okay, second one. Okay. And then that's 2 plus. So add that up. And slide it in. And twist, twist, twist until it clicks. And the last one. What's that? Oh. Okay. So this is 12 gauge wire. Supposedly the hole will take up to 11 gauge, but I am finding that this 12 is a pretty tight squeeze. I gotta get that screw in the right place there. So just keep an eye on those wires. Don't let them jump out on you. Go.
Are we going to do a higher level of channels on this connector?
I mean, we won't in the class, but they do make NL8 connectors. I don't think they've released these XX versions of that yet, but someday. All right, so watch. Here's what has happened. Now you see this little strain relief boot has these little tabs on it. The tabs line up with the notches in the connector there, like that. Okay, and then you get the barrel, and you slide it on. See. Try to find, there's that big thing, and you line it there. There we go. You take it all the way through, so that, like that. And now you get the boot. Get it there. And you can go ahead and do some preliminary twisting, but eventually you're going to need to get this other stuff out. So we're going to stick this thing on. You can see these notches line up with a flat part on that boot. And then here is the torque wrench, and I've got it set to 22 inch-pounds, which is what Neutrik says it needs to be. So I get this thing and I stick it on there. Yeah. Come on. There we go. And here goes nothing. So I'm going to stick this in, I'm going to hold this, and I'm going to twist, 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 and eventually this torque wrench will click. When it clicks, I'm good. Oh, it clicked. Okay, that's it. I'm done. And that is now a UL certified high voltage audio connector that the fire marshal will approve. Hey guys.
Hey, sorry to walk through.
Yeah. So that's it. You need to put one on each end, and then check it, and then you're done. Okay. So I'm going to let you all work on that for a minute, and then a little bit later I'm going to get, because some of you after you do this are going to be ready to start on the cable checker. So in a little bit, let's give it 45 minutes or something, I'll grab your attention again for a minute and show you the information you need to get started on that. Okay? So I think we're good now.